Welcome to Tutor-E Chemistry, where we do our very best to make chemistry as simple as possible. Also, we try to simplify mathematics. So, let's move straight into today's focus, which is on formula of compounds. This is something that is basic chemistry. However, it is a foundational topic. So much so that having problems in this case leads to problems in other parts of chemistry. Because practically in chemistry, you must always deal with compounds and deal with their formulas. So if you don't know how to write the formula of compounds, you start having issues. Just take, for example, how can you balance chemical reactions without knowing the formula of compounds? How can you know the proper products if you don't know the formula of compounds? And for this class, we'll be focused mostly on inorganic compounds. For formula of organic compounds, that is a whole different situation. All right, so the first thing is, what is the formula of a compound? Practically, the formula of a compound is the representation of a compound by using the symbols of the component elements of that compound. Note that when speaking about a single element, you say symbol. But when speaking about a compound which involves more than one element, you say formula. So it would be wrong of me to say what is the formula of, or what's the chemical formula of chlorine. Because chemical formula should refer to compounds. While it will also be wrong of me to say what is the symbol of sodium chloride, because sodium chloride refers to a combination of sodium and chlorine. That becomes a compound. So obviously a compound is a combination of two or more elements. So that's what a formula actually is. However, the main situation here is, how do you get formula of compounds? And it's pretty simple. It is simply by knowing the component elements or radicals, what their oxidation numbers actually is. Now, first thing is, these two words are used interchangeably. Some tell you oxidation numbers, while some tell you valency. At times they are the same, at times they are not the same. So there's a thin line between valency and oxidation number. But because they are used interchangeably for what we are discussing now, check in the link below, where, not even a link, I'll be putting a little PDF material there, which gives each element and some radicals their various oxidation numbers. So if you look at the table, you'll be seeing valency or oxidation number. But like I said, it is actually oxidation number and not valency. Just that in some cases, because of the nature of some elements, valency and oxidation number is the same thing, but they are not always the same. What is valency? Valency is the number of electrons in the outermost shell of an atom. An example, let us use sodium. Atomic number 11. The configuration is 281. What is the number of electrons in the outermost shell? It is 1. So therefore, the valency is 1. Now, what is oxidation number? Oxidation number is the number of electrons that an element will lose or gain when involved in a bond. Mostly ionic bond anyways. So, going back to sodium. When it is involved in a bond, what does it do? Well, it's a metal, and metals most times lose electrons. And remember again, the target is always octet, or in some cases duplet. But in the case of sodium, it is octet configuration. So it loses 1 electron to become 2,8, that's sodium ion. However, the point is that it lost only 1 electron. That makes the oxidation number also 1. So you can see in this case, sodium, the valency and the oxidation number is the same. However, let us take something like chlorine, 17, the atomic number. The configuration is 2, 8, 7. Now, what is the valency? Number of electrons in the outermost shell, it is actually 7. But then again, what is the target? They want to achieve octet configuration. And what does chlorine do? It attracts an extra electron. So for it to become octet, it attracts just one electron. That makes the oxidation number also 1. So you can see, it can be used interchangeably because in some cases, valency and oxidation number is the same. But in other cases, it is not the same. So it is good that you know that thin line, that difference between what valency is and what oxidation number is. However, in the material put in the link below, you are going to be having valency or oxidation number, taking them as the same thing, but try to understand the thin line. And once you know this, it becomes easy for you to get any elements and know their oxidation numbers. Well, besides transition elements, in such cases, you'll be told the oxidation number in the actual question. So let's see, for example, we have let's say magnesium. That's number 12. We have 2, 8, 2. The valency is 2. And the oxidation number, we lose 2 electrons to get octet structure. So therefore, what happens? Its oxidation number is also 2. Check out fluorine, number 9. That is 2, 7. The oxidation number is going to be 1 because it gains 1 electron to get the octet structure. So you can see the way it works. Any element you have, you can simply write the configuration and look at it. How many electrons will it gain or lose? That tells you the oxidation number. However, there are some elements that exhibit variable oxidation states. You have elements like carbon, which do that. That's why you have carbon 4 oxide and carbon 2 oxide. Variable oxidation states. You have elements like nitrogen. That's why you also have nitrogen 2 oxide, nitrogen 4 oxide. As I said, any element that exhibits variable oxidation states, the oxidation number you'll be told in the name of the compound. So you can still guess the formula just by knowing the oxidation number. So that's practically all you need when it comes to getting the formula of compounds. So get the material, download it, and learn them. However, you don't need to just cram them. You can easily know them. Any element at all. This is exactly how you get it. So this is just an introduction. In our next video, we are going to start applying these concepts using the oxidation number, to actually get the formula of compounds. But for now, practice. How can you get the oxidation number of various elements? And I mentioned the word radical. Also try to find out the meaning. We'll speak about them much more in our next video. Just to point out a few things, whenever you have your configuration, elements that have 4 electrons in their outermost shell will most likely exhibit variable valencies. Elements that have 5 electrons in their outermost shell will also most likely exhibit variable valencies. So, or oxidation number. You can see now I'm trying to use them interchangeably. So, once you find 4 in the outermost shell and 5 in the outermost shell, know it is going to exhibit variable valency. But for all others, they are going to have specific valencies, just as we have derived. And then there are certain elements which do not actually react, like helium, neon, argon. Trying to focus on the first 20 elements. They don't react, so don't expect them to have oxidation numbers. Remember again, what are oxidation numbers? Number of electrons that will most likely be gained or lost. These elements have stable configurations, so they will neither lose electrons nor will they gain electrons. So they are always the way they are. All right, so practice, and let's meet in the next video and start to derive the formula of compounds. Like, share, and subscribe.